Well, hello everyone. So welcome to yet another video of vectors. I think this is the 8th video what we are doing for vectors. So please do watch all the 7 videos and come to this video. Right, now coming for the question number 6. Observe here. If Q is given to be 2, 1, minus 2 and R is given to be 0, minus 5 and 1, find the perpendicular distance from the point 1, 4, minus 2 to QR. Right. So just draw the figure. The point is here 1, 4, minus 2 to QR. So Q is given, R is given. Now we need to find this perpendicular distance is what I need to calculate here. Right. In order to find this. So what is our approach? So just think about it. So how can I get D? With respect to the theta, this D is nothing but the opposite side, right? So opposite by hypotenuse. Hypotenuse is QP. I have this vector. So Q and P values is what I have. So I can find out what is QP, which is nothing but QP vector. What is it? OP minus OQ. So OP minus OQ in the sense what? OP minus OQ. So 1 minus 2, that is minus 1I. Next 4 minus 1, that is plus 3J. Next, minus 2, minus of minus 2, plus 2. Okay, so that is anyhow a 0 there. So minus 1I plus 3J is what you have for your QP, right? That is what given here. Anyhow, now, what do you feel that sine theta is? Sine theta is nothing but, as we know, it is nothing but the opposite side by hypotenuse, isn't it? So hypotenuse is our QP. That is the length we need to calculate for QP, not just the vector. Length is nothing but the magnitude of QP is what we find. Now tell me, what is this theta? Theta, is it nothing but the angle between the two vectors? Can I say that? Okay, so what is the angle between two vectors? What are the two vectors? QP and QR, isn't it? So QP and QR, if you observe, angle between QP and QR is nothing but theta. So I can write sine theta is nothing but the cross product. What is sine theta? If you tell me, find it. So it is nothing but A cross B by mod A, mod B, or magnitude A, magnitude B. So similarly, this is also nothing but QP cross QR, isn't it? So QP cross QR upon mod QP mod QR. Now observe what are getting cancelled. QP, QP getting cancelled there, isn't it? So what is your D equal to? QP cross QR upon QR. Please do take mod there. Right. So what is QP cross QR? QP cross QR is what you have. IJK, you please take it and find out the determinant, and that's the way you get your QP vector. Take the magnitude of that QP vector, you'll be getting so-and-so value, and QR, what is the QR vector? So QR magnitude, QR length is what you can find out by taking OR minus OQ. So just subtract it, you will get the QR length also. Hence, you will get your final answer there. Understood? So getting to this point is very, very important. Right. So now going ahead for the next question. Right. So observe this, you have a P equal to A plus B, Q equal to A minus B, and you are given some magnitude of A and all these are also given to us. Right. Right. Now for the question number 4, we have a P vector and the Q vector given to us, magnitude A, B and all given. And the question is regarding, yeah. So magnitude of P cross Q is what they are asking about. Now, how do I proceed with this? Think about it. What is P cross Q according to us? Right? So that is nothing but mod P, mod Q into, this is nothing but sine of angle between P and Q vectors. Agree with that fact? Right? It is based on A cross B, isn't it? What is A cross B? That is nothing but magnitude A, magnitude B into sine of angle between A and B. The same rule is what I have applied. Now, as we already know what is the magnitude of P and Q, magnitude of P and Q, are they giving us? No, I think they didn't give us, isn't it? So we can just calculate that, isn't it, magnitude? if I go by this process, magnitude of P and Q is what I don't have, isn't it? So what is my next approach? Think about it. I am given already P and Q. So why can't I find P cross Q like A plus B vector? Yeah, this is one vector cross A minus B. A plus B cross A minus B. When you multiply them, A cross A, which is 0 vector. Next, minus A cross B. Next, plus B cross A. And next, minus B cross B vector. That's a 0 vector again. Right. So now can I just take minus A cross B as B cross A there? Right? So B cross A plus B cross A, which is nothing but 2 times B cross A is what I have. Now just take the magnitude on both sides. Magnitude of P plus Q is nothing but 2 times magnitude of B cross A. Now, as I have a vector B and vector A magnitudes, I can apply now. Earlier, for magnitude of P and Q, I don't have them, isn't it? So I have to take some other support. I have changed my strategy to this part. Now, this is nothing but mod B, mod A, or magnitude B into magnitude A. B cross A is nothing but mod B, mod A into sine of angle between B and A. All right. Now, when you observe, are they giving us sine of angle between A and B? Look at your options and tell me, what are your options stating us? Options, do we have, just a minute here. Yeah. So in our options, do we have any such thing like angle between these two is what? Do we have them? No, isn't it? So I need to change my strategy again here. Sine of angle between these two, but options are all in A dot B, and A dot B always deals with what? Mod A, mod B, cos theta, isn't it? So hence I need to change this sine theta to cos theta for my proper substitution there. And I know sine square theta is 1 minus cos square theta. So in place of sine theta, I am going to take 1 minus cos square of angle between A and B. Understood that? Now 2 times, and mod A is already given to be R, mod B also to be R. So R into under root 1 minus cos square theta, where theta is the angle between your A and B. Now tell me what is cos theta that we know. Cos theta is nothing but A dot B by mod A mod B. That is what I'm going to apply here. This is 2R square under root 1 minus A dot B whole square by mod A mod B. Whole square again here also. Isn't it? Mod A mod B whole square. Now tell me what is it? Mod A square, R square, isn't it? So this is nothing but under root of 1 minus A dot B whole square by, so what is mod A given to us? R square into R square, that is our R power 4 there, right? Now 2R square outside. Now observe your options, nothing is kept outside. I'm just sending this R square in. So how does that go? So 2 times under root R squares go inside as R to the power 4 minus R to the power 4 into A dot B whole square by R to the power 4. Now do you find your option there? Observe R to the power 4 minus A dot B whole square. Where do we find it? That is your option 2. Understood the question? So what all we have done here, just a quick recap of what we have done. So P cross Q is given for us. When I start with my original strategy, I'm stuck somewhere. Hence, I'm just diverting my question to P cross Q to be A plus B cross A minus B. When you multiply them, cross product of two vectors is always the same. A is always a 0 vector there, isn't it? So A cross A is 0. A cross minus B will be, that is minus A cross B, B cross A, and minus of B cross B, that is 0. So applying that logic, I got 2 times B cross A. Now what is B cross A? Magnitude B into magnitude A into sine of angle between B and A. Now magnitude of B and magnitude of A is already given to be R and R. So just substitute R under root of 1 minus cos square of angle between A and B. Why did I take that? Observe the options. I observe that all my options are in terms of A dot B. And where is A dot B dealing with? A dot B will be dealing with cos theta, not with sin theta. So my thought is like, I need to convert that sin theta to cos theta. So sin theta to cos theta is nothing but under root 1 minus cos square theta is what I can do there, isn't it? So 1 minus cos square of angle between so and so. So now cos theta is nothing but A dot B by mod A mod B. That is what I have applied here. I have every value, just substitute and get your answer finished. That's it, right? Right. For the next question, eighth one, if you observe, vector A, for any vector A cross I whole square plus A cross J the whole square plus A cross K the whole square is what they are asking. Now, options, if you observe, everything is in terms of A only. Right. So do I know the vector what is A? I don't know, isn't it? So I can just take A vector to be any vector that is like xi plus yj plus zk is what I have considered there. Right. Understood? So xi plus yj plus zk. Now the question is regarding A cross I whole square, A cross j whole square and all. Now how do I relate this? Xi plus yj plus zk cross I. Now observe, I cross I, what is it? I cross I is anyhow 0. So x into 0, that is nullified there. Next, y times j cross I, isn't it? Next, plus z times k cross I. This is what we have. Now tell me something. In your I, this is your I, this is your j and k. Tell me what is j cross I. J cross I am going back, hence it is nothing but minus k. So minus yk here. Next, k cross I. K cross I is in a proper direction only, hence I get j. So plus z into j. Zj is the answer for A cross I. Similarly, find out what is A cross j. In the same pattern, you can just find what is A cross J, also your A cross K. You figure out and tell me what they are. So after doing all this, so you will be getting A cross J and A cross K in this way, isn't it? So your A cross J, observe here, this is nothing but I cross J. I cross J is K always. J cross J is 0. K cross J, K cross J, K cross J, you're going in a reverse way. Hence, you will take minus I. Understood that? So why? What is the reason behind that? Right. Now coming for A cross K also, you will do it in the same way. Understand? Now what do you end up with? Tell me. Now, right. So the question is regarding A cross I whole square. So just apply whatever you have. A cross I whole square in the sense what? It is nothing but the magnitude of your A cross I is what you can consider, which means it is nothing but y square plus z square. Actually, under root of that y square plus z square. But you have I A cross I that whole square, isn't it? Or the same thing, magnitude whole square plus x square plus z square. Next, A cross K whole square instance x square plus y square. Now, when you observe what is all this, 2 times x square plus y square plus z square is what you have. Right. So now tell me what is this? 2 times. Is this nothing but your determinant of A the whole square? Your A is xi, yj, zk, isn't it? So determinant of the whole square is nothing but actually, not the determinant, very sorry. So it's the magnitude of A. Magnitude of A is nothing but under root of x square plus y square plus z square. Taken a whole square, under root gets cancelled. You're getting your x square plus y square plus z square. Hence your answer is 2 times magnitude of A the whole square. Understood? Right. Going for the next question. This is the same question as what we have done earlier just now. The perpendicular distance of a point A, let this be point A. I'll start with the point A as capital A with the vector as A there. On to the line, and the line is what? You are given the line as R equal to B plus TC. So can I just treat this like this point is B, my capital B, my vector B. Okay, this is the point B. passing through a point. This is the point, and parallel to vector C. Whenever you have a line equation like R equal to B plus TC or R equal to A plus TB, which is nothing but passing through a point B and parallel to vector C. So let this be parallel to some vector C. Understand? Let this be parallel to some vector C there. Right. Now the question is, what is its perpendicular distance when you drop down a perpendicular? What is this distance is my question. Same logic is what you have to apply there, isn't it? So my perpendicular distance is what I need. For that, let this be some theta there. This is the question what they're asking for. Now theta, apply two logics here. One, that is our regular trigonometry. That is our 10th class based trigonometry, isn't it? So sine theta is nothing but opposite by hypotenuse, which is your AB. Now tell me what is this AB vector? That, yeah, we will calculate that at a later stage, right? Also, theta is nothing but the angle between the vectors. Theta is nothing but angle between vectors BA and BC. And this is nothing but vector C is what I can consider, isn't it? BA and the vector C is what I can consider. BA is nothing but A minus B. Agree with that? OA minus OB. This BA is nothing but A minus B is what I am writing there. Right. And this is the vector C, what we are talking about. Now tell me, what is sine theta? Sine theta always deals with the cross product, isn't it? A cross B by mod A mod B. So A minus B cross C by magnitude of A minus B into magnitude of C. This A minus AB is nothing but the same thing, isn't it? AB or A minus B magnitude or B minus A magnitude is one and the same, isn't it? Magnitude remains the same. Hence, your distance D is nothing but A minus B cross C by magnitude of C. Wherever you find that option, I think the option 2, I guess, isn't it? Right. A minus B, C, and mod C. Fine. So that is your option there. Fine. Clear? Understood the process? Right. Wherever you're not understanding, please just go back a few seconds and check back and come back again, okay? Coming for such a model question, which we have already completed long back, isn't it? You're given magnitude A, magnitude B, angle between A and B also given. Now the question is regarding A plus 3B cross. Now observe the cross product and tell me. So 3 times A cross A, which is a 0 vector, isn't it? So yeah, just let me write. Yeah, this is nothing but a 0 vector. Next, minus A cross B. Next, plus 3 times 3, that is 9, B cross A. Next, 3 times B cross B there, hence it is a 0 vector there again. So now you've got, this is minus B cross A. What is it? Which is nothing but B, minus A cross B is nothing but B cross A, just a change of the direction there. So B cross A plus 9B cross A, is it nothing but 10 times B cross A? Right? Now the question is regarding a whole square of this, which means 10 square into B cross A whole square. How do I get what is B cross A? Think about it and tell me. B cross A, how do I get it? It is nothing but mod B, mod A, and the sign of angle between, isn't it? So this is nothing but mod B, mod A, or magnitude B, magnitude A, into sign of angle between that, which is nothing but 2 pi by 3, right? So which is 100 times the determinant of A is 1, 2, and this is nothing but sine 2 pi by 3, which is same as sine pi by 3, which is sine 60. Yes, that is your root 3 by 2, the whole square, isn't it? So 100 times 3, that is your 300 is the answer for the questions. For the 7th question, option is 300. Right. Going further. Question number 11 here, you are given vector A dot B is given, A cross B is another vector also given to you. The question is regarding find B. Now, how do I find this, right? Now, question number 11, observe carefully. What is the friendship between A cross B and A dot B? Do you remember this? Think about, tell me what is the friendship between sine square theta and cos square theta. Sine square theta plus cos square theta will always be 1, isn't it? Now, what is sine theta? Nothing but A cross B by mod A mod B. Cos theta, A dot B by mod A mod B, but we are talking about squares, hence take these squares. Okay, so nothing but now A cross B whole square plus A dot B whole square, which is nothing but mod A mod B whole square, or mod A square into mod B square is what you can take, isn't it? So can I just apply those values here, isn't it? I am given A dot B is 14. So can I just take 14 square? Obvious, isn't it? Now A cross B is this. Tell me what is A cross B whole square, which is nothing but 3 square 9 plus 1 plus 8 square, which is 64. Antega? Right. So 64 plus 1, yeah, 10 plus 64, which is nothing but 74. So here, what do we have? Yes, this is what we have there. 74 plus 196, isn't it? 196 plus 74. This is what I have, 270. And what is the magnitude of A? Tell me what is magnitude of A? This is nothing but 2 square plus 2 square plus 1, that is 9 under root 9, hence it is 3. So you got a 3 square into magnitude of B, which I don't have there. That is what I'm supposed to find. B's vector is what I need to find there. Right. So 270 pi 9 equal to magnitude of vector B the square. All right. So vector B has got a magnitude of root 30. Agree with that? So magnitude of B is nothing but equal to root 30. Now just check out of your given options, A, 1, 2, 3, and 4. Which one has got a magnitude of root 30? See, observe 5 square 25 plus 1 plus 4. Do we have it? Yes, we have it. 5, 1, 2 combination, we will get. This we will not get. 5, 1, 2, 5, 1, 2 we can get. So these three can be the options. But how do I decide? How do I decide which is correct answer? Think about it carefully. I have three options there. Out of these three options, which one I am going to pick? Go for a verification. Nothing can be best other than the verification for this problem, isn't it? Because A dot B, wherever you are getting 14, that will be your answer. You already have your vector A. Now think this as your vector B. Think this as your vector B. Just take their cross product. Are we getting a 14 or not? Sorry, not the dot product. Sorry. So A dot B, take the dot product and just check whether you are getting 14 or not. If not this, go for A and B as option 3 and then proceed. Check it whether it is 14 or not. If not, A with the option 4 as your B. So A dot B, you just check and find out whether you are getting 14 or not. It is just a verification what you need to do there. I hope you'll be doing that. Okay, right. Now coming for the 12th question. What's given there? A plus, fine. You are given A plus vector B plus vector C is a null vector. Now talk about what is A cross B. Right, how do I get A cross B? See, when I just take A plus B equal to minus C and then taking squaring on both sides is what I am getting a dot product there. So how to get this in the sense, can I just take A plus B equal to minus C? Okay, this is my first step, what I can do. Right. Now I need A cross B. Think about I need A cross B. Hence, can I just take cross B and here also cross B on both sides when I expand this? So this is nothing but A cross B plus B cross B, which is equal to minus C cross B, same as writing B cross C. Yes or no? Right. Now B cross B is anyhow zero vector. So hence I got A cross B is same as B cross C. This is a so simple bit, isn't it? Right. Yes, coming for the area of the triangle formed by 3 points. If I have ABC, what is the area of the triangle? Area of triangle in the vector form, that is nothing but half AB cross AC, cross product of two adjacent sides, AB cross AC. Or it can be, just take mod there, okay? So magnitude is what we need. We need a scalar quantity there, isn't it? So, or it can be also half BC cross BA or half CA cross CB. Got it? So this is nothing but the area of triangle ABC. Now you just have your 3 points ABC. This problem is what I'm not doing at all. You just have 3 points ABC. You can calculate what is your AB vector, calculate, which is nothing but OB minus OA. So OB minus OA, take the difference. OB minus OA, 3 minus 2, which is 1I. Next, 4 minus 3, which is plus J. Next, 2 minus 4, which is minus 2K. Understood that? OB minus OA, that is your AB vector. Similarly, find out what is AC vector, after which you are going to take their cross product. How do you take the cross product? Do you remember? Right. Right. So coming for a quadrilateral ABCD. ABCD is a quadrilateral. 24th question, observe there. So ABCD is a quadrilateral, they said, and AB and AD and AC are all given for us. See, observe carefully. A, B, C, D. So my AB is I plus 2J. AC also given, right? You just have to figure out what that is. So what is AC vector? 2I. All right. Next, plus this is 4J and 3J, obviously 7J. Next, there is no K there. Here we have 3 2s are 6K plus 6K. Right. So that is my AC. And I'm already given AD, I guess, which is a J plus 2K. All right. Right. So now the question is regarding what is the area of the quadrilateral ABCD. Now we have two ways to find this area of quadrilateral. How, think about, I am having AC as 2I plus 7J plus 6K. Can I just find out area of the given quadrilateral as this shaded part triangle area plus the other triangle area? Can I do that? Area of triangle ABC plus area of triangle ADC will give me the complete quadrilateral ABCD. Agree with that? Yes, so AC, so I'll just find out nothing but area of my quadrilateral is area of triangle ABC plus area of triangle ADC. For area of triangle ABC, am I having the adjacent sides? Yes, isn't it? So this is nothing but half AB cross AC plus again here half for ADC, AD cross AC. Understood? So this is a little lengthy way, I would say, because you need to find out the two cross products, their magnitudes, and add. Rather than that, so can I just find out the area of the quadrilateral as half D1 cross D2, isn't it? So half diagonal D1 cross D2. Now, how do I get diagonal 1? I am already having diagonal 1. Diagonal 1 is nothing but 2I plus 7J plus 6K. Now, how do I get diagonal 2, which is nothing but BD? How to get BD? BD is nothing but, according to the triangle law, observe, BA plus AD. BA plus AD. But what do I have? I have BA or AB? I have AB, isn't it? So BA is nothing but minus of AB. So minus I minus 2J plus AD is nothing but J plus 2K. Clear? So now it is nothing but minus I minus J plus 2K. Clear? So I have my diagonal 2 also. Now you can just take the cross product, half D1 cross D2. So half I, J, K. D1 is nothing but you have 2, 7, 6. And D2 is nothing but minus 1, and 2. Take their cross product. It is nothing but the determinant of all this you will be doing. And finally, take the magnitude of that resulting vector because you need the scalar quantity there. Is that clear? Right? Second option would be a better option in solving. Half D1, D2 would be a better choice than going for area of ABC plus area of ADC. Is that clear? Right. Right, coming here, area of a parallelogram. So this is a parallelogram, what we are talking about. Right. So coming for the area of parallelogram. Area of parallelogram is nothing but what? Just the product of the cross product of the adjacent sides. A cross B is what your area of parallelogram is. Right. So your A and B are given to be P plus 2Q cross 2P plus Q. Got it? Now just take the cross product like P cross 2P, which is a zero vector. P cross P is always zero vector, which we have already done many times. Next, plus P cross Q plus 4 times Q cross P plus a zero vector there again. Right, so now I would consider Q cross, this is nothing but minus of Q cross P I can consider because this is a Q cross P, I'm bringing it to that form. 4 minus 1, that is nothing but Q cross P. Right, now you can just take the magnitude of that. You got your P and Q. Cross product is nothing but magnitude of Q into magnitude of P into sine of angle between Q and P. Right. Observe here P and Q are unit vectors forming an angle 60. Clear? So 3 into 1 into 1 into sine 60, which is nothing but root 3 by 2. Hence your final answer is 3 root 3 by 2. That is your option 2. Understand that? Right? All easy questions. Just try it your way. Right. Now for the question 28, you are given OABC is a quadrilateral. OABC is a quadrilateral. OA vector is A I have written. OB vector is nothing but 10A plus 2B. OC vector is B, wherein A and C are non-collinear points. Fine. P denotes the area of the quadrilateral OABC. We have just now done, isn't it? So what is the area of quadrilateral OABC? It is nothing but half D1 cross D2, out of which what is D1? You're already having that. That is 10A plus 2B. Now coming for what is D2, how do you get it? D2 is nothing but AC. How do you get AC? OA plus OC, triangle law. AC is nothing but, AO, starting with AO. Okay. So AC is nothing but AO plus OC, right? So we are given AO or OA. OA is given as A. So AO will be how much? Minus A plus OC is already given, which is B. Understood? So that is your D2. Now my question, this is nothing but half D1 cross D2 is nothing but the area of quadrilateral. Clear? Let P be that. So P is nothing but the area of quadrilateral, half D1 cross D2. So half into. Now talk about what is D1. 10A plus 2B cross D2 is minus A plus B. Take the cross product carefully. Zero vector. Next. 10A cross B. Next. Minus 2B cross A. And the other one, obviously, 0 there. So B cross A can be written like plus 2 times A cross B here, which is half 12A cross B. Understood that? So this is what we have. Now coming for what is Q? Q, they said, small q, right? So Q is nothing but what? Q denotes the area of parallelogram with OA and OC as adjacent sides, isn't it? So Q is nothing but area of parallelogram with just adjacent sides are given. What is the area of parallelogram? It is nothing but OA cross OC, isn't it? So what is OA? OA is given A. OA vector is nothing but A cross. What is OC given? B. Wonderful. Now tell me what is P by Q? You're already having Q here. P is there 6 times A cross B. Q is there A cross B. Question is regarding what is P by Q? 6 times A cross B upon A cross B. Hence answer is 0. Finish. Clear with that? Right. Coming for the next question 34, that is you are given U vector and V vector and magnitude of A and B vectors to be 2. Question is regarding what is U cross V magnitude. Obviously, this we have done many questions of the same type today. I want you to go ahead with these questions. Clear? So A cross B cross A, sorry, A plus B cross A minus B, isn't it? A cross A 0 minus A cross B, next plus B cross A, next the other one is 0. Right? Is this nothing but 2 times B cross A taken mod? Isn't it? Now, what is B cross A? B cross A is nothing but 2 times mod B mod A sine of angle between A and B. Understood? Now, this is nothing but 2 times B cross A. So, 2 into mod A is nothing but 2 each. So, 2 into 2. Again, our answers are in the form of A dot B, which we have done in the beginning of this series, of this session. We have done such a problem. We have sine, but we want A dot B, which deals with what? Cos theta, isn't it? So I need to rewrite my sine theta as under root 1 minus cos square of the angle between A and B. Right. Now, what is the cos theta? Cos theta is nothing but A dot B by mod A mod B. The whole square is what you can consider, which is 8 times under root 1 minus A dot B whole square upon what is A dot mod A mod B is already given to be, I think, 2 into 2. 2 into 2, 4, 4 square, 16, I guess, right? All right. So now just send the 8 inside. How does it transform? Right. So you can just apply that. Basically, I will just split this like 2 into 4 and I'm going to send 4 inside. 2, I will remain it outside. 4 can just go inside like 16 into 1 minus A dot B whole square by 16. Right. So 2 times under root now 16 minus A dot B the whole square. Because you find 16 there, I'm just trying it that way. I'm not sending the whole 8 inside. Because look at my options also. According to the options is what I need to proceed with the questions. Right. So if I send 8, what happens? If I directly send 8 inside, what happens? It becomes a 64, which is of no use for me. I have 16 in my options. So 4 is the value that I need to send in. So 4 goes in as 4 square, which is 16 there. Clear? Understood? So that's how you get your answer there. Coming for the question number 45, perpendicular distance of a point 6 minus 4 and 4 to the line joining the points A and the point B. This is, I think, the third problem what we are doing today, third type, same type of problem. I think the third one is what we are doing today, right? So think about what did we do here? I have just drawn a perpendicular. I have considered that to be distance V, taken theta there. So I know that sine theta is nothing but opposite by hypotenuse, that is my AP, which is same as theta is nothing but the angle between the two vectors AP and AB, isn't it? So sine theta is nothing but AP cross AB by AP mod into AB magnitude. So obviously AP gets cancelled. Your distance D is nothing but AP value. You just find out what is this. And AB also you find out what is this vector and the determinants find out the answer. I am not going to solve the problem. Clear? Right. For the question number 44, so we are given a vector A and vector B is given for us. And also given the point of intersection of the lines R cross A equal to B cross A. Also, R cross B equal to A cross B. These are the two equations given for us. Now tell me something. R cross A minus B cross A equal to 0 vector, which means can I just take R minus B cross A equal to 0. Now tell me, cross product of two vectors, when can that be 0? See, cross product always deals with sine theta. Sine theta is nothing but A cross B by mod A mod B. Now, when does this cross product become 0? When this is becoming 0 in the sense theta is nothing but 0. which means they are parallel vectors, isn't it? So I can say R minus B is parallel to vector A, isn't it? So when it is parallel, obviously R minus B is some scalar multiplied by vector A. R minus B is nothing but lambda A. Clear? Similar way, figure out what this is. This is also R minus B minus A cross B. Sorry, A cross R cross B minus A cross B equal to 0. So obviously R minus A cross B equal to 0. Next what? Here also we got a cross product. So this cross product, when can that be 0? Cross product 0 అయింది అంటే when the lines are parallel. Dot product when it is 0. Dot product is 0 when the lines are perpendicular. Remember that. Okay. Right. So here we have R minus A is parallel to the vector V. Obviously, R minus A equal to, I would take some K into B. Okay. So there it is, R minus B is lambda A, R minus A is KB. So from here, R equal to B plus lambda A, which is equal to, from here, this equation, A plus KB. Now observe carefully and tell me what could be the values for lambda and K which satisfies this equation. Think about it and tell me. See, you have B here, you have KB here, which means your K should be equal to 1 only. When you compare these two, lambda A and 1A, which means lambda also equal to 1. Clear with that? So what could be that point there? The intersection point. So you can substitute in any of these. So either in this equation or in this equation is what you can substitute. So R equal to B plus lambda A, wherein lambda is 1, which is nothing but B plus A. Now just find out what is B plus A and write your answer there, finish, isn't it? So what is your vector R? That is what B plus A, 2 plus 1, that is a 3I plus J minus K. So 3I plus J minus K, that will be your answer there. Understood? Right? Wherever you're not understanding, please just go a few minutes back, revisit the concept again, just see what happened there, take a pause, solve it yourself and check you'll get it, okay? Yes, now question number 18. So you have G is the centroid of the triangle PQR. Let me draw the figure PQR. They said G is the centroid. Right. GP, GQ. Okay, this is GP and GQ is what I am joining. GP and GQ. I am given vectors for GP and GQ. Then the triangle, area of the triangle PQR, the whole triangle area they are asking. Now tell me, area of triangle PQR, when you are given this shaded part area, is it 1/3 of the complete area or not? When G is the centroid, we have a rule that this centroid divides the given triangle into 3 equal areas, isn't it? Clear? So all these are the 3 equal areas where your triangle is divided into. So obviously area of triangle PQR will be 3 times area of triangle GPQ. Understand? So now area of triangle GPQ is nothing but what? Half GPQ. You're already given GP and GQ. So area of triangle in terms of vectors, half into cross product of the adjacent sides. That is your GP cross GQ. Just to take their cross product, GP and GQ take their cross product, 3/2 times the cross product of that value is what you get your answer to be there. Clear? Everywhere I am not doing the cross product. You please continue solving it. I, J, K values. You just take these 3, figure out what is the determinant for that and you finish the answer. Clear, Nana? Yes, for the next question also, that is the 22nd question, you are given vector, magnitude of A and magnitude of B, and angle between A and B are given. Then the area of the triangle with the adjacent sides are given to you. So what is the area of the triangle given? The adjacent sides are half into cross product of the adjacent sides. So that is your A plus 2B cross 2A plus B. I think you can be solving this. This also was done many times. A cross A obviously 0, A cross B this and this. You just figure out. Later you will be getting some cross product value there. Just apply the cross product value, that is mod A mod B into sine of angle between so and so A and B. You are already given these two angles. Just substitute and you get your answer. Finish. Okay. So yeah, so that's it for today's class, and we'll be meeting you in the next video. Hello everyone. So let us continue with the problems based on scalar triple product. What exactly do you mean by scalar triple product? So triple product, in the sense, it's a product of three vectors, and how are we going to multiply them? One dot with one cross. See, observe, when you have vector A dot B cross C, right? So A is a vector and B cross C also another vector. When you take the dot product, you are going to get a scalar quantity, isn't it? So this is called a scalar triple product. When you are multiplying three vectors in such a way that your resultant is a scalar, you call it as a scalar triple product. Whether you call it A dot B cross C or A cross B dot C, A cross B dot C. So whether you do it that way or this way, you get one and the same answer, and that is represented like box ABC. Clear? It's a determinant of the all these three vectors ABC. Box ABC is same as writing the determinant of all the three vectors ABC. The vector components, all these you'll be writing and find its determinant, right? So now coming for what is the volume of a parallelopipe with the coterminous edges. So if you observe a parallelopipe, this is a parallelopipe, right? So what are the coterminous edges? So when you observe this as your origin, so observe these three. This is x-axis, that is your y-axis, and this is your z-axis. So coterminous edges are from the origin O. These three values, when you observe OX, OY, and OZ. So these three are our coterminous edges, we call them. These three are given by three vectors A plus 2B, 2B plus C, and 3C plus A. Understood? Right. Now they have also given the box ABC notation to be a -4 in the question. Now what do you mean by box ABC -4? When your box ABC is negative, is less than 0, it is a left-handed system. Understand? So remember that this is left hand. When ABC is greater than 0, it is your right-handed system. When box ABC is equal to 0, all three vectors are coplanar is what we can say. These are the three main conditions. Remember them. Right. Now coming for the volume of a parallelopipe. Right. So it is same as writing determinant of these three given coterminous edges. Determinant of the three coterminous edges along with ABC, box ABC. Reason being, the given system is oblique system. It is, isn't it? So A bar, B bar, C bar notations are called as oblique system. Hence, you always multiply that with the box ABC. Understood that point? So let's go by solving 1, 2, and 0. So let us write these values 1, 2, 0. Next 2b plus c. There is no a component, hence it is 0 with the 2 and 1. Next 3c plus a. C component is 3. A is 1. B is 0. Right. Now you just have to calculate the determinant of this times box ABC. Now what is the determinant? Just let us quickly calculate and tell me. So here we are getting, so 1 times 6 minus 0 and minus 2 times the 0 minus 1. So you will be getting 6 minus of minus 2, 6 plus 2, that is 8 times minus 4, hence it is minus 32. So now you might think about why is the volume in negative, right? Now we are talking about left-handed system, isn't it? So in order to make the volume positive, negative of negative only gives us a positive answer, isn't it? Hence, we are going to just take that negative sign into consideration because minus 32 is supposed to be our correct answer. Do not mistake it to be 32. Clear? See, when you observe mod x equal to x if x is greater than 0 we take, and mod x equal to minus x if x is less than 0 is what we consider. Why are we considering this minus sign? Because we have to convert that minus negative value to positive by taking another negative sign, that is minus of minus positive. Understood. So hence that is the reason why we are including a minus sign in our answer definitely. Is that clear? Right? So minus 32 is only our answer there. Now, going for the next question, that is 15th one. Volume of the tetrahedron with the edges as 1, 2, and 3. You are already given the coterminous edges. See, remember one thing. When you are given 4 points, A, B, C, D, what we need to do there? We need to calculate OA, OB, OC. These are the things what we need to consider. Or if you are given AB, AC, AD. Okay, A, B, C, D are the points when given to you. A, B, A, C, and A, D are the vectors what we need to find, because points, they do not have any life in vectors. They have to be converted to vectors by combining two points there. Understood? So you need to make the edges there and hence state them they are coplanar or whatever it is. Now coming for the 15th question, you are already given the edges there. So this is one edge, another edge is given to you. Now, what is the volume of a tetrahedron formula? That is 1/6 of the given, yeah, box of your given three vectors. You can call it to be A, B, and C vectors is what you can calculate. So it is just finding 1/6 of the determinant of these three vectors. You don't have to multiply with A, B, C because this is not an oblique system. Is that clear? It's a right-handed orthonormal system only. We can go ahead directly. Understood? So question number 15, I think you can be able to solve it on your own. The formula is what I'm writing. Volume of tetrahedron is 1/6 of a box ABC is what you can calculate. Given your ABC are the three vectors which are the coterminous edges is what I can say. So it is 1/6 of determinant of 2, 1, 1. Next 1, A and 1. And next we have 1, 2, and -1. So just find the determinant. And they said, see, the volume is 1 cubic unit is what they said. Equate to 1. Resolve this and get the value of A from there. Understood? Is that clear? I hope you can be able to solve this on your own. Right. So just finding the determinant and equating it to 1. Calculate your A value. You will be getting it. Right? I'm not solving this problem. Hopefully you can do it on your own. Right. Now going for the vector equation of a plane passing through 1, 2, and parallel to another vector. See, observe here, I am given a vector A and a vector B passing through points, they said. Okay, let me take this as point A and point B. Right. Next, parallel to another vector C, let it be. Understood? So I have 2 points here. Let me draw the figure first. Let us try to understand what it is. So I have point A and a point B. Equation of a plane which is passing through these 2 points is what they want. And there is another vector which is parallel to this vector is what they wanted. Let this be vector C is what I consider. Understand? So for getting this equation, how do we do it? Now try to analyze what we are doing here. See, I have a vector C which is parallel to the given plane. Can I just bring it down on my plane? Understand, as in math, we are dealing with free vectors. They are not localized vectors, isn't it? They are free vectors. So this C vector is what I can bring it on my plane as such. Right? Now, in order to get the equation of a plane passing through some points, right? So let me consider create an artificial vector by some point P, that is vector R there, position vector. This is A and this is B, right? Now observe carefully, AP, AB are my two vectors is what I can say. Along with that, the other vector is C. All these three are now coplanar, I can say, isn't it? Now, which three vectors are coplanar? My AP, AB, and vector C are coplanar. When these three vectors are coplanar, obviously their box equal to 0 is what I can consider, isn't it? Understood? So, just framing equation in this way, that's it. Right. Now, when we talk about AP, is it same as writing R minus A? AB, is it same as writing B minus A? And vector C is direct vector C, which is given to you there. Understood that? Now, what is R minus A? R minus this A is I minus 2j plus K is what I have written. That is my point A. Next, B minus A. This minus this. Observe carefully and write. I do not have any I component. So, hence I take a minus I there because 0I minus I. Next, J component. Observe carefully. Minus 2j here. You have a minus 2j with minus of minus 2j plus 2j, isn't it? So then there is no j component plus 0j. Next, going with the k components, that is a 3k minus k. Hence, that is plus 2k. Understand? So next, the another one is vector C directly. Directly, you can write it. That is your 2i plus j plus k is your vector C. Now equate it to 0. That's it. So now where do you find this option? Just check where do you find this option. Minus I plus 2k. I think it is, yes, 2. Second option. Right? Understood, everyone? Right. Okay, let's go ahead. So AP, AB, AC. I hope you all clear with that. Now, observe question number 22. The vector equation of a plane passing through one point and parallel to two vectors. Now, observe the figure here. Now, this is passing through one point only. Point will not have anything to do in vectors. It always has to be combined with another point in order to frame an artificial vector. Hence, I am going with the point P that is got a position vector R. Point A with a position vector A, and they said the equation of a plane passing through the point A, this is my point A represented like this, and parallel to B and C vectors is what I am considering. This is parallel to some B and some C vector there. Obviously, as they are free vectors, I can just bring them down. This is my B vector and that is my C vector is what I can say. Now observe carefully. What are the three vectors which are coplanar? The three vectors which are coplanar are A, B, and C. That's it. Their box is same as 0. Their scalar triple product is always 0. So AP, B, and C. AP in the sense this is same as writing R minus A. R minus A. R minus what is your A? I plus J plus K. This is given A. R minus A. Next B, next C. So where do you find that option? I think option 1, right? So the first option is it the same thing, right? So that's it. So that is your question number 20 there. Now going with the next question. Right. Now observe this question. You have A, B, C are three non-coplanar vectors and P is given like B cross C by box ABC, C cross A by box ABC and A cross B by box ABC as your Q and R. Now the question is regarding 2A plus 3B plus 4C dot P. Right. So this is dot P vector and this is so and so dot Q vector and this is so and so dot R vector. Now I am just trying to expand this very carefully. Now try to observe A dot B cross C, isn't it? The first with the complete B cross C. So A dot B cross C is always to box ABC. That is fine. Everyone knows that. Next coming for B dot B cross C. Now think about when you have B dot B cross C. Is it same as writing box BBC? Right? Now, when you are writing box BBC, it is the determinant of the B vector and C vector, right? So, B vector and C vector is somehow different there, right? Now, when you have, when you have these three vectors in which two lines are same, exactly the same, two rows are same, hence its determinant is always 0. Hence, you will have, when you have a repetition of the vector in the box product, in that box, it's always turning out to be a 0. So, you have B dot B cross C, which means it is box BBC, hence it is 0. Next, C dot B cross C, again a repetition of C, hence it is 0 there. There it is closed. Next, go with the other part, that is 2 times B dot C cross A. So that part will be existing, isn't it? Plus 2 times B dot C cross A. So hence it is BCA there. Next, C dot C cross A. Obviously C dot C cross A. Repetition of C, hence it is 0. A dot C cross A, repetition of A, hence it is 0 again. Next, coming for the third one, that is 2C dot A cross B. Hence, I can go with a plus 2 times, that is CAB, 2 times CAB vector. Clear? Next, again, A dot A cross B, 0. Next, we have B dot A cross B, also 0. Now, tell me something. This is a rotation. When I bring A here, that will be A, B, C. A rotation will not carry any sign change. When you are doing with your determinants, the rotation will not carry any sign change. If you are replacing your BC with CB, just BC is replaced as CBA, then yes, you will get a definite negative sign. But here you won't be getting any such negative signs. Clear? There's a repetition of the whole vectors you are doing in the determinants, hence your sign will not be changing there again. Here also I'll write this C there, hence it's again a rotation of the ABC vectors what I'm doing, hence it is also to box A, B, C. Right? So finally, we got 6 times box ABC there, right? Upon ABC everywhere. So 6 times box ABC upon box ABC. Hence your answer remains to be a 6 there. Understood? These both get cancelled. Final answer remains to be 6. Is that clear? Multiplication while you're doing it, many terms are getting 0 there. They are getting nullified because 2 rows are same. Whenever, remember this thing, whenever you have 2 rows of the determinant, finding determinant while you're finding determinant, 2 rows are same, hence its answer is 0. Hence, if you have BBC, answer is 0. If you have CCA, your answer is 0. Is that clear? All these will be nullified. Done? Right, going for the next question. Right. Now coming for the question number 16, you are given box ABC is 4. Question is regarding A cross B, B cross C and C cross A की box. Right. This is same as writing ABC whole square. Hence your answer is 4 square. Hence that is 16. Now but why? Why is it ABC whole square? Just think about it. So is this a scalar triple product of the 3 vectors? This dot this cross this, right? So let me write A cross B, yeah, A cross B dot B cross C cross C cross A. Understand what I am doing here? Right. Now, while I am taking their cross product, see, observe B cross C. It's a scale, it's a vector cross product is what you can, triple product is what you can consider. That is your B cross C dot A times C. This is your B cross C dot A times C. And this can be considered like BCA box with the vector C. Next, minus the same B cross C dot C. This is your B cross C dot C times A. Right? So minus, what is B cross C dot C? This is box BCC, and box BCC, you have a repetition of C. Hence, this results is nullified. That is 0 there. Right? Understood? And what is the rule that we have used? Observe A cross B cross C is same as writing A dot C into B minus A dot B into C. This is the rule that I have applied. A dot C into B minus A dot B into C. This rule is what I have applied considering B cross C as a single entity there. Clear? Now I am left with dot product of this A cross B dot BCA into C. These are the only 2 things left. BCA is same as your scalar quantity. BCA is what I am writing in this way. Now I am left with A cross B dot A, which is my ABC box. Here also take a repetition, ABC times ABC, that is your ABC box whole square. Finished. That is the reason why you got A cross B, B cross C, C cross A as A, B, C, the whole square taken under box there. right? So now when that is 4, this will be your 4 square. Answer is 16. Right. Now going for the next question, that is 19th question there. Cartesian equation of a plane passing through the 3 points. Passing through the points 1 and 2. 2 points. It is passing through 2 points and parallel to the vector. Now draw the figure. Figure is always most important. Passing through point A and point B, and they didn't say that this is parallel to vector. They said this is parallel to some vector, but they didn't mention that whether it is on the line or not, on this plane or not, right? So another vector is the vector C is what I will consider. This is my C vector passing through point A and point B. Right, I hope this we have already done such a model. So a point does not have any authority to do here in vectors. It has always to be framed with an artificial vector, that is point P taken as R. This is my A vector and this is my B vector. So hence I go with AP and AB, and that as they are free vectors, that C can be brought on to this. And now we have 1, 2, 3, 3 vectors AP, AB and C to be coplanar. Hence what I can say, AP, AB and vector C are coplanar. Hence their resultant is equal to 0 there. The box of this equal to 0. You figure out what is AP. We have just done the similar kind. So your P is same as writing your R, that is AXI plus YJ plus ZK. With AP in the sense you can just take X minus 4 and Y minus, all that you do it. And AB also you figure out what is AB. AB is same as writing B minus A. AP is same as writing R minus A. C vector remains the same. C vector is what you calculate. You just take the determinant, equate it to 0, figure out what is the expression there, what is the equation of the plane there, right? Now, so these are the questions where you need to understand the figure there. So what exactly is the situation, what they are giving? Find the vector equation of a plane containing the line. Now observe, this is my plane. My plane is containing my first line, that is R equal to, this is my vector R, which is passing through point A and parallel to B. B can be somewhere here. It need not be there only. Okay. So this is passing through point A. So you please mention point A. The plane has got a point A. This is my point A I can consider. This is passing through point A and parallel to B. Right? So the equation of a plane containing the line. This is the line where it contains and parallel to another line. So this is another line which is somewhere outside. This might be here. I don't know where it is. It is not on the line. They didn't mention that it is on that plane, right? So my other line is C plus TD. Understood? C is the point through which the other line is passing and D is somewhere, anywhere outside is what also I can consider. Now I am talking about what is the equation of that plane. Now think about it carefully. This line is parallel to vector B, that is as it is local, as it is free vectors, I can bring that vector B here. And this line is also, the other line is also parallel to vector D, that also I can bring it down here. Hence, I can conclude I have my R that passing through point A. Hence, I will represent by some point P with my R there, which is AP is one vector, B is one vector, D is one vector, which are these three are coplanar, isn't it? AP, I have three vectors now, AP, B and D. All these three are lying on a same plane. Hence, their box equal to 0 is what I can consider. So, what is AP? Which is R minus A. B with D equal to 0. So R minus A, B, D equal to 0. That is my equation of a plane passing through the given line and parallel to another line. So please rewind it back again and check which plane is the equation what they're asking for and which is the line which is lying on that plane and which is the line which is parallel to the plane. Clear? Going for the question number 3, there ABC are three vectors, non-zero and non-null vectors. Okay. R is any vector in space. Then what is box of BCR into A, CAR into B, and ABR into C? What is this equal to is the question, right? Let us solve this now. Now, when I consider R as the vector R as XA plus YJ plus ZK, XA plus YB plus ZC is what I consider, right? So XA plus YB plus ZC is what I am considering. Now my question, the first part is what I'm trying to solve. Observe carefully. Now BCR box into A. Now is this same as writing B cross C vector dot my R vector. R vector is XA plus YB plus ZC. Clear? Only this box is what I'm just trying to figure out. So this part, yeah, just a minute. Right. Now when I'm multiplying B cross C dot XA, observe these three. So is it box BCA into X? Isn't it? So this is X into box BCA. Understand? Along with that vector A is what I have written here. This box expansion is only till here. Along with that vector A is what I have written here. Understood? Now, similar way, I am going to calculate what is CAR. See, observe CAR box into vector B. Right. Now, is the same as writing C cross A vector dot, this is again XA plus YB plus ZC. Clear? This is my box expansion. This box expansion only. Now C cross A dot X dot A. Now C, this is X times C cross A dot A. That is CAA. Hence its resultant is 0. Now I'm going with this CAB. Yes, I will get this CAB box with Y there along with the vector B here. Right? And what is the other one? That is my A, B and R. A, B, R. R is again XA plus YB plus ZC is what I consider with A cross B dot this. This part only I'm talking about, right? Now, this will be 0 because A cross B dot A, B, A repetition there, hence results in 0. Next, A cross B dot B, again B and B repetition 0. And now observe A cross B dot C, which is your ABC box. ABC box with Z along with the vector C there. Understood? Now, whether you call BCA, which is same as writing ABC, here also same as writing ABC, here also ABC. Now in these three, I am just going to add them both, all these three. Now when I add, what do you get? This is same as writing BCA or ABC box taken common. Again, now it is XA plus YB plus ZC. XA plus YB plus ZC. Is it equally good as writing your R there? Isn't it? So it is same as writing your box ABC times your vector R finish. That is your option C. Clear with that question? Right. Going ahead with the next one. Now, going with the question number 4 there, you've got your A, B, C vectors. These are coplanar. So, all these three vectors are coplanar. They didn't mention that they are points, hence you don't need to worry at all. So, you can directly take A, B, C box equal to 0. So, that is the determinant form is what you mentioned. 2, minus 1, 1. 1, 2 and minus 3. 1, 2 and minus 3 along with the 3 mu and 5, this determinant equated to 0. Just to get the value of a mu, what is it from here? And substitute that mu. As they said, mu is the root of the equation. It should satisfy your x values. So wherever, whichever equation is satisfying in all these four, you'll get it. It's just the determinant equated to 0 because all the three vectors are coplanar is already given for us there. Clear? Understood? Right. Now going ahead with the next question, that is 5. You are given three vectors A, I, J, K and I plus B, J plus K or whatever it is. Yes. Now let us go with that question. All right. Question number 5 here. Now they said again these three vectors are coplanar, most important for your matrices also, isn't it? So right, now I'm just taking as these three are coplanar, their box is 0. When their box is 0, the determinant is 0 there. So A1, 1 I consider, next it is 1B1, and next it is 1, 1 and C. Determinant of this equal to 0. Now my question is regarding 1 by 1 minus A plus 1 by 1 minus B plus 1 by 1 minus C. Now how do I deal with this question? I need to get this structure here. So structure is what very important. I have 1 minus A, 1 minus B, 1 minus C is what I need to somehow get in that determinant. Now how am I going to do that? So now can I just replace my column 1 as column 1 minus column 2. Observe what I'm getting. So that is my A minus 1, 1 minus B, and 1 minus 1, 0. A minus 1, 1 minus B, and 1 minus 1, 0. Keeping 1, B, 1, 1, 1, C the same, equated to 0. Now, what is the other thing what I can do? I'll be getting A minus 1 or 1 minus is what I can manage there. 1 minus B is also what I have, but I don't have 1 minus C. Hence, can I do my column 2 is changed like column 2 minus column 3. So, A minus 1, 1 minus B, and 0 remains the same. Column 2 is what I'm changing there. So, 1 minus 1, 0. That is my B minus 1 and 1 minus C. Remaining 1, 1 and C. Is that clear? Right. Now finding the determinant of this is our task. Just find the determinant. How do I find it? So A minus 1 times this minus this. Okay. And this is 0. Are we going in a proper way? 1 B minus 1 and 1 minus C also fine. Right. Okay, let me calculate. So now I've got A minus 1 times the determinant when I'm equating this to 0 is this C times B minus 1 minus of 1 minus C. This into this minus this into this. So B minus 1 times C minus of 1 minus C. Next, 0 into anything that is anyhow nonsense there. You can just end it up. Next, plus 1 times 1 minus B times 1 minus C. That is what I have. Now, figure out what it is equated to 0. Now, A minus 1 is anyhow there. This is CB minus C, CB minus C minus 1 plus C. All right. Oh God. Yes, these two got cancelled. 1 minus CB is what I'm left with. Am I getting it to that form? Let me observe. I need to get 1 minus A, 1 minus B, and 1 minus C. Right. Okay. What else changed? All right. So from here, I'll be writing A minus 1 into B minus 1 into C minus A minus 1 into 1 minus C. I'm just expanding this into this and this into this plus 1 minus B into 1 minus C equated to 0. Right. Now try to understand the form what they're asking us here. So we want 1 minus A, 1 minus B, 1 minus C. Okay. So that 1 minus A, 1 minus B, 1 minus C, how am I going to get? So because A minus 1, B minus 1, I'll just take a negative sign common. C times I will write 1 minus A and 1 minus B. Same form. Here also A minus 1 is there. So when I take 1 minus A, so that will become a plus here. I will get 1 minus A. Now with 1 minus C, fine. Next, plus 1 minus B and 1 minus C equal to 0, also fine. Right. Now, which one do I have to divide the whole with? When I divide the whole with 1 minus A, 1 minus B, 1 minus C. So this is my 1 minus A, 1 minus B, and 1 minus C is what I am dividing the whole. Here also 1 minus A, 1 minus B, and 1 minus C. Obviously, there it is becoming a 0 there, right? Now, terms are getting cancelled here. Observe here. These two got cancelled. 1 minus A with 1 minus C also. 1 minus B along with 1 minus C also got cancelled. I am left with C by 1 minus C plus 1 by 1 minus B plus 1 by 1 minus A equal to 0. Now, basic question is here. They are asking regarding, observe, 1 minus A, 1 minus B, 1 minus C. But we got C by 1 minus C, which is, this part is what still irritating us, isn't it? So this is the part which is still irritating us. So hence, when I have to remove this, what do? I will just add 1 on both sides. See, just a balancing part, what I'm doing here, plus 1 and plus 1 here. What do you get here? So you got 1 minus C. This is C plus 1 minus C. These both got cancelled. So are you left with 1 by 1 minus C plus 1 by 1 minus B plus 1 by 1 minus A is what you're expected to prove there, which is equal to 1. This is supposed to be your answer. This is a most important question for your matrices chapter also. So try to understand the importance of this question. Right. So you need to somehow manage to get that structure of 1 minus A, 1 minus B and 1 minus C without completely expanding that. Okay. Complete expansion not to be done for such questions. Remember that. Here, when you're expanding, here in the earlier steps, we went wrong while we were expanding. So never ever expand for such questions. Get it to that structure. Structural questions are most important kind. Clear? So you need to do some operations for matrices here for finding the determinants and all. Along with that, you will be calculating. You will be left with one unknown with some two values here. So that also you will be eradicating if you just take plus 1 on both sides. Clear? So that's how you got your question there. Right. Going ahead for the next question. Right. Now for the question number 9, observe there, X into A cross B plus Y into B cross C plus Z into C cross A is your vector R given for us already. And your ABC, box ABC is 1 by 8 is also given. The question is regarding what is X plus Y plus Z. Now, given such a question, in order to go to that form of how to find X plus Y plus Z is really difficult. But when you look at your options, observe your options, R dot A, R dot B, and R dot C. Here also you have R dot A, R dot B, and R dot C. Here also you have the same pattern. So figuring out what is your R dot A, R dot B, and R dot C might be giving us our proper answers. Now observe what is R dot A. Yeah. So for this is all my R. Observe till here, all this is my R. Clear? Now, this dot A, if I am doing, observe very carefully and tell me, A cross B dot A, is there a repetition of A and A there? For A cross B dot A, that is box ABA. And box ABA is 0 because there is a repetition of vector A. So first part is 0. Next, for the second part, Y into B cross C dot A. BCA, there is no repetition. So hence I will get Y into box BCA, fine. Next is third one, Z into C cross A dot A. Again, there is a repetition. A is a repetition there again. Hence, CAA box is always 0. So R dot A is this. Right? Now, similar way, figure out what is A dot R dot B. Now, when I'm multiplying the whole with B, A cross B dot B. Again 0 there. B cross C dot B. Again 0 there because B is a repetition there. And Z times C cross A dot B. So this is Z into, this is C A B is my answer here. Now same is the way, can you calculate it for the other one and tell me? Right. Now go with C there. Now I want what is R dot C. Now for getting R dot C, A dot B, A cross B dot C, which is ABC box, right? That I have. So X times ABC is what, not a problem there. Now coming for B cross C dot C. B cross C dot C. Obviously C is a repetition, hence it is 0 there. C cross A dot C. Also C is a repetition, hence it is again 0 there. Now it's just addition of all these three. When I am adding all these three, what am I getting? This plus this is A, B, C box. When I remove that, I will be getting, what do I get? This is same as writing X plus Y plus Z, isn't it? So this is X plus Y plus Z. So my R dot A plus B plus C is so and so is what I got, and ABC box is again 1 by 8 is already given for us here. So 1 by 8 times X plus Y plus Z. Right. Now my question is regarding find X plus Y plus Z. So this 8 is taken to the other side. Is it same as writing 8 times R dot A plus B plus C? Option C is my answer there. Clear? Understood? So for such questions, only if you have options, you will be able to do them. Only for this is only for your objective type is what you can guess. What are you supposed to find? Looking at the options is what you need to understand the strategy behind the question and proceed with the question. Is that clear? Right. Now, for any non-collinear vectors P and Q, then find the value of I P Q into I, J P Q into J, K P Q into K. Now, observe this carefully. PQ, PQ, PQ is what you find common everywhere. So, why can't I take, see, is this same as writing I dot P cross Q? I dot P cross Q. Clear? Here also J dot P cross Q. Right? So, for writing this, now what I write is P cross Q, let it be sum Xi plus Yj plus Zk. It will be there, isn't it? So I can write it that way. Xi plus Yj plus Zk is what I'm thinking about P cross Q. Right. Now, what is I dot P cross Q? Think about the first step only I'm doing. The first one only. I dot P cross Q. So is it same as writing I dot Xi plus Yj plus Zk? Isn't it? Right. Now, what is this I dot so and so? Is it same as just writing X or not? That's it. Clear with that question first, right? Because I dot J and I dot K is obviously 0, isn't it? So here you got X. Now coming for what is J dot, what is J dot P cross Q? In the same way, if you observe. So this is J dot P cross Q is again Xi plus Yj plus Zk. Now, when you are multiplying this, J dot J is what you got your Y value to be. Here you got a Y there. And obviously, the other part you will be getting Z. Clear? Which I'm not doing, which you can do it. So now finally, I got X plus Y plus Z. Now, clear with that? So that is X plus Y plus Z. Now, multiplied by I here and J here and K components. Fine. That's it. So this is my X, this is my Y, and this is my Z. So Xi plus Yj plus Zk is what my final answer, which is same as writing your P cross Q. So option 4 is your answer there. Clear? Right. Now going ahead for the next question, if the vectors A, B, and C are given this way, and these are three coplanar vectors is what they're telling us, just try to split the determinant given there, right? Just split the determinant and you'll get your answer very easily, right? So for the question number 5, I am writing A, B, C, A square, B square, C square with 1, 1, 1. Clear? That is my first determinant. Plus, here we are getting A, B, C with A square, B square, C square along with A cube, B cube and C cube here. Is that clear? Right. Now, can I just take something common? So when I remove A, B, C common, what do I get? So if I remove A, B, C from the first row, second row, third row, I'll be getting 1A, A square, 1B, B square, 1C, C square. Right? So when I just replace it here, it's same as writing 1, 1, 1 and A, B, C, A square, B square, C square determinant is what common I found along with the 1 here plus A, B, C there which is equated to 0. Now, the determinant of this can't be 0. Hence, your ABC, 1 plus ABC equal to 0, which means ABC equal to minus 1. Is that clear? So that's how you end up there. Right, going for the next question. Ninth one. So your alpha is so and so, B cross C and Q times C cross A and R times A cross B is given. And if alpha dot A plus B plus C is 1, then what is ABC is our question there. Right, going ahead with this. Right, now this question is what we have already done in the previous session, like just a few minutes back, is what we have done. The same with R here. The same question, exactly the same type of question, right? So now the question, when you are given alpha is already given for us. The question is regarding what is alpha dot A plus alpha dot B plus alpha dot C. Now tell me what is alpha dot A. While you are doing alpha dot A, now this whole dot A while you are doing B cross C dot A, which is P times BCA box. Next, C cross A dot A, which is 0. A cross B dot A, which is 0 because A is repetition there. Right? Now, same is the case with, now what is alpha dot B? Right? So, what is alpha dot B? Now, tell me, alpha dot B. How do we do that? Again, I'm just erasing this part. I'm writing what is alpha dot B. Now, dot B here and the whole dot B. Right. Now, when you observe this, B cross C dot B. B is a repetition, hence it is 0 there. C cross A dot B. So, hence I will get Q times CAB. Next, A cross B dot B, hence it is a 0 there. Now, the final one, that is alpha dot C. Alpha dot C, if I do, this is 0, and ABC. So, that is R into box ABC. Right? This is also ABC, this is also ABC, and this is also ABC. While I'm adding all these three. So, alpha dot A plus B plus C, if I am doing, which is same as A, B, C taken common, you will be getting a P plus Q plus R. Right. Now, what is this P plus Q plus R? The question is regarding what is box ABC, isn't it? So, obviously, this is 1 they said. So, 1 by P plus Q plus R is your box ABC. That's it. So, 1 by P plus Q plus R. That is your answer there. Clear? Right. So these are a few questions on the scalar triple product. The next coming video will be solving few more questions on scalar triple product, and we'll be quickly moving ahead with our vector triple product. There ends our complete vector spaces. Right. So good luck. Bye-bye. This is Charitha signing off from PACE Hyderabad. Thank you.